Hello my lovelies, it's Susanna, and today I want to show you how to find the local extrema of the function f. This is the function we work with, and you can always take these 4 steps to find the extrema of your function. Step number 1, find the derivative of f. So we want to find f prime of our function f. For this, we take a look at our function and see that it is a polynomial function. So these pluses tell us that we have 3 parts here, and we can differentiate each part separately. So we start with this part here, and the rule is that you take your exponent and multiply it by the number here in front of your x. So you do 3 times 2 over 3, and then you decrease your exponent by 1. So instead of x to the power of 3, we only have x to the power of 2. Then the same with the next part. Here we take the exponent and multiply it by the number in front of our x. So it's 2 times 3, and we decrease the exponent by 1. So it is x to the power of 1, or just x. And then the same with the last part. Here we apply the same rule, but the fast way of doing it, if you just have an x here, so if you have x to the power of 1, this x will disappear when you differentiate, and only the number in front of your x will stay there, so we only have a 4 here. This is our derivative, but let's just simplify it a little bit. We can cancel the 3 out here, so we have 2x squared plus 6x, and then the plus 4. This was step number 1. Number 2, set the derivative to 0. So we take our derivative, which is found, and set it to 0, and now we solve this equation for x. It's a quadratic equation, so we could use the quadratic formula to solve for x, or, because the numbers look so simple, we could try to factorize the right side. But before we do that, I want to get rid of the 2 here to make it easier, so I divide both sides of the equation by 2. Here we have 0 over 2, which is just 0. And here I have to divide every part by 2. So we have 2x squared over 2, which is just 1x squared. Then 6x over 2 is 3x, and 4 over 2 is 2. Let's factorize the right side. We want to get x squared, so x is going to be my first part here and here. And then we have to find numbers a and another number b, that if I multiply these 2 numbers, then I have to get this number here where we don't have any x as a result, so a positive 2. And if I add these 2 numbers that I still have to find, then I have to get this number here in front of my x as a result, so the 3. Which numbers are possible if I multiply them that I get 2? It would be something like 1 times 2, or -1 times -2, and always check the second condition as well. So if we add the 2 numbers, I have to get a result of 3. So if I have to add 1 and 2, I already get a result of 3. So these are my numbers, a 1 and a 2. So I take a as plus 1 and my b as a positive 2, and now I have a product here on the right side equals 0, and this is only possible if either this part here equals 0 or this part here equals 0. So I can split this one equation into 2 simpler equations. So either x plus 1 equals 0, or my second parenthesis, x plus 2 equals 0. To solve this first equation for x, we just subtract 1 on both sides of the equation to get x. these two cancel out, and on the other side we have a -1, my first solution. And here, to solve the second equation for x, we subtract 2 on both sides of the equation. Then we have x here, these two cancel out, and on the other side we have a -2. We found two solutions to our equation here, a first one, x1, and a second one, x2. And these are now my critical points, and I will work with them. So I take these solutions here with me. This was the second step. And now in the third step, I check with the number line. So what does this mean? We still want to find the local extrema of our function. We found the derivative so far, and we found these two critical points. And now we have to determine whether we have a maximum at this point, or a minimum at this point, or if it is a saddle point. And we use a number line to determine which is the case for this point here and which of these is the case for the second here. So let's draw a number line, and we will use our critical points we found so far. So the -2, I put it in here, and the -1, I put it in here in red. And now I need numbers to the left of my critical points and to the right. So to the left of the -2 would be a -3. To the right of the -2, so far there is another critical point, but I need another point in between. So I can't just have a critical point next to my other critical point. So I need a number between -2 and -1. Any number you like. I just take the middle, so it's -1.5, or as a fraction, -3/2. And then I need another number to the right of this critical point, which would be just the 0. So pick numbers you like to the left and to the right of your critical points. And now we plug these numbers into the first derivative, because the first derivative gives us the slope of our function. And then we can find out whether before my critical point my function is increasing or it is decreasing. Because if it's the case that it's increasing and after my critical point it is decreasing, then I know that I have a maximum here. And if it's after my other critical point here, it is increasing again, then I know that I have a minimum here. So this is our plan. We take these numbers here and plug them into the first derivative. So f prime of our first number of the -3. 2 times. Then for the x, for every x we can find, we plug in the -3. So we have -3 squared plus 6 times -3 and then the plus 4. We are only interested if this result is positive, then my function will increase, or if this result here is negative, then my function will decrease. So we have -3 squared equals 9, so 2 times 9 equals 18. Then 6 times -3 equals -18, so we have 18 plus -18, which just cancels out, so we just have the 4 as a result, which is positive. So we can type in this here. My slope is positive, so my function will increase before this critical point here. Then I want to find out what happens after my critical point. So I take this number here and I put it in the first derivative as well. So I calculate f prime of -3/2. So for every x I plug in -3/2. I square it here and then the same here at this part, and then I have the plus 4. Is this positive or negative? Let's start with a square here. So a negative number squared is going to be positive. 3 squared equals 9. 2 squared equals 4, so I have 2 times this result. Then plus 6 times a negative number is going to be negative 6 times this fraction here, and then I have my plus 4. Here I can reduce the 2 and the 4 by 2. 2 over 2 equals 1. 4 over 2 equals 2. So as a result, I have 9 over 2 here. I can write it this like this. Here I can do 6 over 2, which is just 3. So I have 3 times 3, which equals 9. So I have negative 9 plus 4, which is negative 5. And then I just have to do 9 over 2, which is 4.5. And if I subtract 5, I know that it's going to be negative. So I know that my slope in this area here is going to be negative. This means that my function is decreasing till my next critical point. And now I want to know what happens after that. So I take the 0 and put it in my function as well. So f prime of 0 means 2 times 0 squared plus 6 times 0 and plus the 4. Here we have 0, 0 plus 4 is just 4. As a result, it's positive. So I know that here in this area, my function will increase again. So now I see what happens. My function increases till this critical point, and then it decreases. So I have a maximum here at x equals negative 2. So here at this point, I have a maximum. And then it decreases till my critical point, and then it increases again. So I have a minimum here at negative 1. So I know that I have a minimum here. So this was the third step. We checked our points. And now, as a final step, we just have to find the y-coordinates. So we know we have a minimum at x equals negative 1. We know we have a maximum at x equals negative 2. But we want to find the y-coordinates of these points. So our first x-coordinate is negative 1. We will search for the y-coordinate here. And for our second point, our x-coordinate is negative 2, and we will search for our y-coordinate as well. Let's start with the first point. We take the negative 1 and plug it into our f function, not f prime. This is one of the most common mistakes, that people plug it into the derivative, but we just want to find the y-coordinate. So for every x we have here, we plug in the negative 1. So f of negative 1 is 2 over 3 times negative 1 for my x to the power of 3. Then we have negative 1 in here again, and then here as well. So 2 over 3 times negative 1 to the power of an odd number is going to be negative. So we have negative 1 here. Then here we have negative 1 squared, which is going to be positive. So it's just 1 as a result. And then 4 times negative 1 is negative 4. We have 2 over 3 times negative 1, which is negative 2 over 3. Here, 3 minus 4 equals minus 1. We can add these two numbers by writing the 1 as a fraction, 1 over 1. Then we have to have the same denominators, so we need a 3 here, so we multiply by 3. So we have 3 over 3. Negative 2 minus 3 equals negative 5, and we take the denominator, so our result is negative 5 over 3 for our first y-coordinate. And then the same for our second point, so this time we take the negative 2 and plug it into our f function. For every x we can find the same thing. 2 over 3 times negative 2 to the power of 3, then as well here for this x, and then again at the end. Here, 2 over 3 times negative 2 to the power of 3 is negative, and 2 times 2 times 2 equals 8. Then here we have negative 2 squared is going to be 4. 4 times 3 is 12. And here 4 times negative 2 is negative 8. If we subtract these two, 12 minus 8, we get a result of 4. And then we have 2 times negative 8, which equals negative 16 over 3. We want to add the 4 here, so we write it as a fraction 4 over 1. We need the same denominator, so we multiply by 3. 4 times 3 equals 12, and 1 times 3 equals 3. Now we are allowed to add. Negative 16 plus 12 equals negative 4 over 3, and this is our y-coordinate of our second point of our maximum. Okay, that was the fourth step. We found our extrema of our function, and I hope that you now know how to do it. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!